Hi dear students, in this section we are discussing about extended complex plane and its spherical representation. Okay, so often in complex analysis we have concerned about the functions which tends to infinity as the variable approaches to some point, right? So we know that like that. So that functions in the limiting case actually. So what kind of that point is known to be pole. You might be knowing that, okay? Pole. To discuss this kind of situations, we are introducing extended plane of complex numbers. That is, we are including the point at infinity to the complex plane. So that is C infinity is equal to C union infinity. Okay. So and also we will introduce the distance function on this C infinity, so that we can discuss its continuity properties, which assumes at infinity, right? Okay. And so we have to give a concrete picture for. First of all, we have to give the concrete picture for C infinity. What is C infinity? How it can be identified? That's the process that we are doing. That's the actually spherical representation. Okay. So how actually we can represent C infinity as a unit sphere in R3. There is a one-one correspondence between C infinity and a unit sphere. So we will do that. Okay. So that we will let us take. Okay. So the unit sphere is, we have the unit sphere in R3 is we have x1 square plus x2 square plus x3 square equal to 1. The set of all points such that x1 comma x2 comma x3 belongs to 3 such that this is equal to 1. You might be knowing, right? Okay. So this sphere is known as a Riemann sphere. So what we will do is, you can see here, this is the sphere. Okay, this is the north pole of the that point is 0, 0, 1. This is the real x1 is the real axis, and this is the imaginary axis. This is the plane of complex plane. Okay, this is the complex plane actually. See, this is the complex plane. It intersects the sphere through the equator. Okay, and this x1 is the real axis, and this is the imaginary axis x2. So the points in complex plane can be treated as x1 comma x2 comma 0, right? So as we are considering as a subset of R3, you can have like this, right? And this is the sphere. So what you are going to do is, we are identifying C infinity as the points on this sphere. Okay, let us see how we will do. So this is the sphere what we are having here. It is okay. This is the north pole, which is 1, 0, 0, 1, and we are identifying once more. We are identifying C as the points x1 comma x2 comma 0, and this C cuts the sphere as along the equator. Now what you are having is, for each z in C, consider a straight line in R3 through which z and n. We are joining a straight line with the point small z on C to capital N. So for each z in C, okay, for each z in C, what we are doing is straight line considering z to n. Actually, this intersects the sphere at a point capital Z, which is clearly not equal to n. Okay, and Z. So this point is, we are identifying with this point on this sphere, capital Z. Now you just see, if whenever this is a unit sphere. Okay, whenever mod z is greater than 1, it will be here, right, outside of this circle. Okay, so mod z greater than 1 will be the points out here, right, outside of this circle. So what you are having is, so it will be in the upper hemisphere. So when you will join n with n, there is capital Z will be in the upper hemisphere. Okay, so northern hemisphere. If mod z is less than 1, here you have the mod z is less than 1. So it's inside of this, right? So when you will join here, what will have in this, the point will be in the downward sphere. Okay, so downward southern hemisphere. And also if mod z equal to small z anengil, what will have, mod z is equal to z, what will have this, it will be on the surface, right? So what will happen is it is on this surface. That is that both point will coincide. So whenever mod z small z is here, that will be the same. So whenever mod z equal to 1, we have small z equal to capital Z. Okay, so like that we will identify. One more time, whenever mod z is greater than 1, it will be in the upper hemisphere. So what we will have, when we will join here, it will be here. And whenever mod z is less than 1, you can join. How you will join? You will join like this, and the capital Z will be the southern hemisphere. Okay, whenever mod z is equal to 1, that is it is on here, it will get coincide, right? So capital Z will be equal to small z will be equal to same as capital Z. Okay, so like that we will identify the points here of the complex plane on the sphere. Okay, now you see, whenever small z is tending to infinity, so it will go as whenever small z tends to infinity, what will happen, the capital Z will clearly approach to, you can see here, will be approach to, if whenever z tends to infinity, what will have, it will approach to capital N. So the point at infinity will be identified as capital N. Okay, so we identify capital N and at the point at infinity in C infinity. Okay, thus C infinity represented as the sphere S. So the sphere as C infinity. Okay, now you understood. Okay, now let us see this. What is the idea behind this? What is the common sense behind this? Let's see here. What you are doing is, we are wrapping a sphere with a sheet. Okay, how will do? നിങ്ങളത് മുകളിലേക്ക് കൊണ്ടുപോകുമ്പോൾ what will have, അറ്റത്തെ പോയിന്റ് ഇൻഫിനിറ്റിയിലുള്ള പോയിന്റ്സുകൾ എല്ലാവരും കൂടി ചേർന്നിട്ട് ഒരു പോയിന്റ് ഇവിടെയാവും അല്ലേ വരുന്നത്. സോ ദാറ്റ്സ് ദ കോമൺ സെൻസ് ബിഹൈൻഡ് ദിസ്, ദാറ്റ്സ് ദ ഐഡിയ, കോമൺ ഐഡിയ ബിഹൈൻഡ് ദിസ്. വൺസ് മോർ യു ക്യാൻ സീ ഹിയർ. സോ ദിസ് റാപ്പിംഗ് തുറന്ന് ഇങ്ങനെ നോക്കൂ, ഇതിൻ്റെ ഇവിടെ അടിയിൽ അടുത്തുള്ള പോയിന്റ്സുകളൊക്കെ ഇവിടെ തന്നെ കിടക്കും, ഇവിടെ അടിയിൽ തന്നെ നിൽക്കുന്നത്. ഓക്കെ, കുറച്ച് ദൂരമുള്ള പോയിന്റ്സ് ഇവിടെ മുകളിലേക്ക് വരും. സോ അറ്റത്തുള്ള ഇൻഫിനിറ്റ് ആയിട്ടുള്ള ബാക്കി അറ്റത്തേക്ക് പോകുന്ന പോയിന്റ്സുകൾ എല്ലാവരും കൂടി ചേർന്നിട്ടുള്ള എല്ലാ അറ്റത്തുള്ള പോയിന്റ്സും കൂടി ചേർന്നിട്ട് എന്ത് ചെയ്യും, മുകളിലേക്ക് റാപ്പ് ചെയ്യും. അപ്പോൾ അതെല്ലാം കൂടി ചേർന്നിട്ട് മുകളിലുള്ള ഇൻഫിനിറ്റ്. സോ ദിസ് എ കോമൺ സെൻസ് ബിഹൈൻഡ് ദിസ്. സോ ദിസ് വാട്ട് വി ആർ ഡൂയിങ് ഇസ് C infinity is identified as this sphere. Okay, so this figure just shows the points, how the points are given here. Okay, now let us see. So let us explore this representation. Entana representation, let us see. Okay, so what we have is small z is written as x plus iy. So that's a point on the plane, and capital Z is written as x1 comma x2 comma x3 with the corresponding point on capital on the sphere. Okay, now we will find the equation expressing x1 x2 x3 in terms of x and y. Okay, so for that what you will do is, we know that small z and capital Z is joined, right? Small z and capital N join ചെയ്തിട്ടുള്ള line. So what is the equation of the line joining small z and capital N is Tn plus the point 1 minus t into Ez, where minus infinity less than t less than infinity. Okay, but what is capital N? Capital N is the pole 0 comma 0 comma 1. So what you have, you can have substitute that, and capital Z is, small z is the point x comma y. So when you will substitute here, you will get the equation of the line as the points. Okay, the points 1 minus t into x comma 1 minus t into y comma t. Okay, this is the line points on the, so this is the line in R3 through Z and N given by these points. Okay, hence we can find the coordinates of capital Z. So we can find the values of t. Okay, values of t at that extended plane. So let us see, since the line intersects at Z, we have Z, I don't know, at Z the points have the following property, that x1 square plus x2 square plus s3 is equal to 1. So whenever it touches the sphere, what you have is the 1, which is equal to 1 minus t whole square x square plus 1 minus t whole square y square plus t square, right? So what we have here is 1 minus t square is equal to, you can take all those things, 1 minus t whole square into x square plus y square, which is equal to 1 minus t whole square into, this is mod z square, right? So therefore what you have, whenever mod is z not equal to infinity and t not equal to 1, okay, that is, let's suppose t not equal to 1, there's a point on this, t not equal to 1, that means z not equal to infinity, small not equal to infinity, we have t is equal to, what you have, you can cancel all those things and you will get it as t is equal to mod z square minus 1 divided by mod z square plus 1. Here one mod z square plus 1 is there. Okay, so let's see. So now the again you substitute, therefore the x1 is equal to, what you have, the point is 1 minus t into x. So when you will substitute is 1 minus t, for t we are substituting mod z square minus 1 by mod z square plus 1 into x, so you will get it as 2x by mod z square plus 1. Okay, similarly you will get x2 and you are getting x3. Okay, where capital Z equal to x1 comma x2 comma x3. So what you are getting is the point, you are getting the points of point of Z in terms of small z. So what you are having is, so you can substitute here. Okay, so what is x actually? X means a real part, right? So what you are, how you will get z plus z part. So x1 you will get in terms of z, x2 in terms, so you will get in terms of z, and x3 in terms of z. So we are identifying capital Z as the points z plus z bar by mod z square plus 1 and minus I into z minus z bar by mod z square plus 1 and mod z square minus 1 by mod z square plus 1. Okay, so now if the point of z is given, suppose if z is given, let's suppose z not equal to n, okay, and we wish to find out small z. Okay, but how you will get, you have to identify let's suppose t is equal to x3. Now you substitute here for all these values. So what you have is, so we have z is equal to x plus iy. So you know that what is x plus I, x is equal to x1 by 1 minus t. Okay, plus I into x2 by, from here you have, we got x1 is equal to 1 minus t into x, x2 is equal to 1 minus t into y. So from that we will get x is equal to x1 by 1 minus t. So from that, when you substitute here, you will get x1 by 1 minus x3 plus x2 plus I into 1 minus x3. Okay, so you will get in terms of small z in terms of capital Z. Okay, so we have, so what you have done is, here we are identifying each point of Z. There is a one correspondence. Whenever you have an Z, you can find out capital Z, and you have a capital Z, you can find out a point small z in on the plane. So there is a one correspondence between this C infinity, C and this sphere, and we are identifying the next the point infinity to capital the north pole. So we have a one correspondence between this small z and the C, the extended plane to sphere. Okay, now so you got a concrete picture of a C infinity, that's a Riemann sphere. Okay, now what we are going to do is, we are going to give a distance function on C infinity. So how you are giving so z dash belongs to C infinity, we are going to define distance functions from z to z as the distance between the corresponding points of capital Z dash, okay, as measured in R3. So we are imposing a distance function on C infinity using the Raymond's usual metric on R3 as considered as a points of S. Okay, so what we have it dz dash whole square is equal to the distance whole square is equal to, otherwise dz dash is equal to what you have, x1 minus x1 dash whole. Suppose capital Z is x1 comma x2 comma x3 and capital Z dash is x1 dash x2 dash x3 dash, then what you have is this is equal to x1 minus x1 dash whole square plus x2 minus x2 dash whole square plus x3 minus x3 dash whole square, right? It will be whole raised to 1 by 2, so you can have square here. Okay, so when you will expand this, you will get like this, and which is equal to 2 minus 2 into how you are getting this. We have, since these are a points on sphere, what you have, x1 square plus x2 square plus x3 square equal to 1. So when you substitute that all, you will get 1. Okay, 1 plus 1 you will get, and x1 dash square plus x2 dash square plus x3 dash square will be there one term. So 1 plus 1, it is equal to 2 minus 2 into this one. Okay, you can have x1 x2 in terms of z points, right? So it will be in terms of z point and x1 dash will be in terms of z dash point. So when you substitute here, you will get like this. So what you are getting is, when after all the calculation, you will get it as dz dash is equal to 2 into modulus of z minus z dash divided by root of, okay, 1 plus mod z square into 1 plus mod z dash square. Okay, we have all root of, okay. So what is dz z dash? dz z dash is equal to, the z and z dash are points of C infinity. So it is equal to 2 into modulus of z minus z dash, this is the usual metric on R, divided by root of 1 plus modulus of z square into modulus of 1 plus modulus of z dash square. Okay, in the similar manner we can get for z in this also. So what you can have is how you will define. So one more point is there, right? So you need infinity. So what is the distance of infinity? With z dash is equal to, you can give capital N is equal to 0, 0, 1. So what you have is dz comma infinity. A point of infinity will be the same, will be equal to what you have, that point x1 x2 will be 0, 0, 1. So when you substitute that, we will have 1 2 by root of 1 plus mod z square. Okay, that is 2 by 1 plus mod z square whole raised to 1 by 2. So this correspondence between these points of S and C infinity is called stereographic projection. Okay, that is, this correspondence between the points of S, that is from the points of Riemann sphere to the points of C infinity, is called stereographic projection. Okay, so this is the first section. Let us go through all those things. Any doubt you please ask. Thank you.